Okay. Good morning, good afternoon, good evening to our listeners out there. Who knows what time zone it is? How's it going, Danilo?
Hi, Pete. Very well, thanks. Thanks for today. That's great.
Yes, yes. So, by way of introduction, Danilo is a IEEE fellow and works at ST Microelectronics and a big supporter of the Edge AI Foundation. My name is Pete Bernard, CEO of the Edge AI Foundation. You are at Edge AI Talks, which is our kind of bi-weekly live stream about all things tech talks in the Edge AI space. And I see that we have lots of people coming into the chat. This is a live stream, so you'll be able to ask questions. And hopefully our guest and between ourselves and our guests will provide some answers. Yeah, hopefully you'll learn something. So today we have a special guest, and
Indeed.
indeed, yes. So Professor Vijay Janapa Reddi, who is also a board member for the Edge AI Foundation, but he's also on the board of ML Commons and a professor at Harvard University, and has been a real pioneer in this space. So I think it's going to be exciting to talk to him. Mostly about this is the topic here is mostly around generative AI in this kind of edge space and this kind of tiny ML, edge AI, ML sys space, right? Which has been sort of the thing that's been happening. Before we get Vijay on, I want to do a couple of public service announcements. One is that for those that are going to be in and around Amsterdam in September, I know it's August and we're all sort of chilling, but planning ahead in September, our whole community is going to be at the Things Conference in Amsterdam. It's kind of September 23rd, 24th. We're going to have a bunch of Edge AI partners there, talks, panels. It's going to be a nice party. So the Things Conference is traditionally been sort of a LoRaWAN kind of low power wireless conference, but now it's really expanded to sort of all things on the edge. And there'll be lots of different communities there, so we'll be there. So I want to give a little PSA out for that. And if you go to Edge AI Foundation /events, you'll see information about that as well. I would say also, since you're watching this, you should probably subscribe to our YouTube channel and our LinkedIn, all that good stuff. And then also mark your calendars for November 11th and 12th. We'll be in Taipei with the community there at a big event, a couple of days of talks and demos and workshops around this topic, Edge AI topic. And so that's another one to mark your calendars for if you happen to be in the Taiwan area or want to take a really long flight and get over there. That'd be cool. So those are my PSAs. Let me bring on Vijay. There he is.
Hi, folks.
Sir.
Ciao,
In fact,
Vijay.
Hi.
we're going to give you the special guest layout here. So
Pete, you have way too much fun pushing all those buttons.
So now you got the spotlight. But welcome, Vijay. Thanks for joining us today.
Thank you for having me.
So how are things in Cambridge, Massachusetts, our fair city?
Ooh, that's $1 million question. I'm not sure what
It
that
is.
should
I think it's $1 billion question.
That'll take up the whole hour. And I guarantee you that that'll probably be more entertaining than just the core technical discussion.
But we appreciate you being here and doing all that you're doing for the cause, as they say. But yeah, so you're dialing in from Massachusetts on the East Coast, which is great. So I mean, Danilo and I know you pretty well, and a lot of people know you pretty well. Can you give us your little background, or give us your
Yeah, I'd say first and foremost, I'm a computer architect. Broadly, what that basically means is that someone who's dabbling with hardware and software interfaces, and this includes obviously enabling systems to run much more efficiently. I think that's always the holy grail of building systems as an architect, and that often involves how do you think about where the workloads are going, which is going to be obviously the topic of discussion today. Then thinking about in terms of how do you get the efficiency, which is very relevant to Edge AI, obviously. And then kind of trying to bake that down all the way into silicon. And I think it's a fascinating time in industry. I kid you not, and I say this all the time, which is that, my gosh, what I would do to be a student just so I can actually have time to do real work.
Yeah. Yeah. No, it is. It's an amazing time, such a transformative time. It feels like every week there's a new breakthrough and a new thing happening in the space. And so, yeah, being a student, just kind of soak it all in would be fantastic.
Yeah.
Good. So why don't we kind of get into it a little bit? The topic is generative AI at the edge. It says generative AI at the edge, challenges and opportunities. That's the title. So I think that's where we need to stick on topic. And we're going to get people can throw questions in there. It says here cannot hear him. Patrick says cannot hear him. So I don't know if you can lean in or I don't know if we can make some adjustments. I heard you.
Yeah.
Yeah, me too.
Folks, well.
Yeah. Okay.
Yeah.
We can adjust mic settings a little bit. I can juice it up a little bit.
I'm not sure I can change though.
No, I see. I added volume a little bit, so
Okay.
I can do that remotely here. Okay, so Tia says she can hear him, and so can Christopher. Okay, we're good. Thank you.
Okay.
All right. Yeah, why don't we start with kind of and Danilo, feel free to chime in. I think one of the things people should also know is the AJA Foundation has a lot of working groups. And one of our working groups is called Generative Edge AI, and Danilo is the co-chair of that working group. And for those that want to really dig into hours and hours and hours and hours of content on this, you can go to our YouTube channel, and we hold these marathon live streams over multiple days on this topic. And we've done that several times now. So there's a whole bunch of talks from folks around the industry about what's state of the art in generative AI at the edge on our YouTube channel, part of Danilo's working group. And so he's kind of been soaking in this topic as well. But maybe we should start with kind of definition of terms. There's this term generative AI, Gen AI, there's transformer models, there's agentic AI. I mean, how do you talk about what is what?
I think today generative AI is basically used quite broadly. I
Yes.
think that any aspect of AI, I think people just kind of lump into generative AI. And traditionally, I think generative AI used to mean explicitly generating new content, but I don't think that's quite true in terms of how everyday people kind of think about it.
Mhm.
Because nowadays it's more about generating new content with a little bit of context. Right. So what that often means is that you are actually mining into some actual data and pulling out the data and then sort of synthesizing it. So I think generative AI has kind of evolved from the classic, academic term of what it really was, which is purely generating new content.
Mhm.
Now I think it's more about looking at a little bit of the past, mining that data, understanding what is actually relevant, and then sort of synthesizing something new out of it.
Right. And so how does that relate to the term like transformer architecture? Like
Well,
transformer
that's sort of the building block, right? I think generative AI is basically just a new kid on the block, but the fundamentals have never really changed. I think that's the most amazing thing for all the discussion that we hear at the surface where people are like, oh my gosh, AI is changing so rapidly and all kinds of things are happening. Well, that's like to me saying that, wow, there's so many Lego sets and I can't keep track of all the different Lego sets that are coming out every single day across the world. I'm like, yeah, but Lego is Lego. You got a handful of pieces, and those are the building blocks. And the transformer architecture is sort of like the Lego piece. You only have n number of Lego pieces you're going to make, but out of that, you can compose them in really fascinating ways to create many different kinds of Lego sets. And I think that's what's the best analogy I can think of in terms of what's moving really fast in the industry versus what's actually happening underneath the hood to enable a lot of that innovation.
Right. By the way, they come out with new Lego pieces all the time too, just as kind of
Those are like the new widgets.
a little extra, the little extra funky pieces. Yeah, so you have the architecture, which is transform models, and that, contrast that to sort of like what we've been using in the AI vision space, right? Which is more CNN, RNN type architectures, which is different, right?
Yeah.
So that's more of like a comparative kind of AI as opposed to generative AI, maybe, right?
Well, I think like generative AI has got a long history. If you kind of go back, everybody looks at the transformer block and says, "Oh, this transformer is this whole new sort of way of doing things." Well, yeah, it sounds like that if I give you, yes, a really good flexible piece. But if you open up the transformer architecture itself, it's really built on a lot of the original fundamentals of spatial processing from CNNs, sort of paying attention within those mechanisms, I mean, they came up with, different kind of attention mechanism, but attention originally came from a different group, the core attention principle. And then it's like, of course, there were sequence to sequence models that were kind of created where you kind of track information history. And so there's a lot about the history of how a transformer architecture has actually come about. Is really building on old principles with a new approach.
Right.
Maybe one word, Peter. But Vijay, I was touched about one of your comments previous times, saying generative AI is not just transformers, and transformers are not all we need for generative AI. Can you little bit comment on that for everyone to enjoy?
I think for generative AI, the way we look at it in production systems today, if you're talking about having a generative AI in the real world, what I'm trying to say is that there's a core element of generation, but it's often shrink wrapped around a whole lot of other code, right? So for example, the simplest example would be like whenever you use ChatGPT, it's not like the prompt that you write is exactly what goes into the model, right? There's a lot of pre-processing that's actually done on the prompt, right? And maybe you're asking for some explicitives and so forth, and that those get filtered out immediately. You don't even need to fire up a ginormous trillion parameter model and waste all that energy. And after the system actually generates it, you're still going to post-process the data because you want to really be sure you're not producing something that actually violates some sort of human rights issues or whatever, right? So all of that is really the generative AI package you get, right? Now I think like the transformer architecture and all these principles are more like the engine in the car, but the car is more than just the engine, right? And I think that's what's sort of important, is kind of keeping that pipe in mind. And I think a lot of people, especially in the industry, get so wrapped up in that core engine and then forget that, okay, well, I can't have a Formula One race car stuck in a Prius. It's not going to work.
Right.
And I think so that's the point that I was trying to get to, Danilo.
Yeah.
Makes sense. So there's also the term like the people, well, I would say to your point, I think a lot of people are using the term generative AI just to mean AI in general. I mean, it's really become so mainstream. When it starts to be on CNBC, then at that point the horse is out of the barn. So we've lost it. So it is what it is. But there's also people also use the term agentic AI, right, and using agents and as kind of an intrinsic kind of, I don't know, derivation of the use of generative AI. But so where does agentic AI fit into the terminology puzzle?
So I would say that's sort of like that packaging element in some capacity, right? So generative AI, if you kind of think about that sort of as being the new engine now, right? That's got all the horsepower that you need. Then the agentic thing is all about sort of, looking at planning around, okay, I ask you to do something. Well, the system has to sit back and look at what are you asking me to do? So then it's got to come up with a plan, right? So most of the generative AI models nowadays end up look like reasoning models because they're trying to understand what did you ask, trying to break that down into a sequence of different things that it has to actually do. And then basically from that, actually figure out how to act on those actions that, it came up with as a plan. And after acting, then the idea is actually reflecting back on it and then adapting, right? So sometimes like you'll see like, these generative models, if you just go back a year ago, would say something, but then they would just kind of stop there. And then when you prod them about it, then they'd be like, oh, well, yeah, like you're right. Like, I didn't mean that. I'm sure we've all experienced this with ChatGPT. But today's models are effectively self-reflective, right? In the sense that they actually generate the output and they actually question themselves, like, does it sort of make sense coherently? And if so, then they kind of say, okay, yeah, I'm good to give the user whatever he or she wants. If not, they kind of say, okay, well, no, actually, I have to tweak this a little bit further because I have some sort of misunderstanding here.
Right.
So I think so this notion of planning, acting, and then dynamically adapting and doing all of that autonomously without the human in the loop is fundamentally, for me, the definition of agentic frameworks.
Yeah, that makes sense. And then there's also the term mixture of experts, which is kind of a technique of using multiple generative AI models to sort of correct each other, right?
Yeah, I would say the mixture of experts really kind of comes from it's an architecture of implementation. At the end of the day, it's just sort of how you actually realize it. Do you just kind of build one massive model, or do you kind of break the problem down and do a bunch of different experts who are kind of orchestrating, the result at the end of the day?
Right. Yeah, lots of terms out there. Danilo, did I miss any?
Maybe one point, Vijay. Well, there are a lot of things, and I would really take advantage of having you here and ask many, many things. But generative AI at the edge, what sort of complexity, model size, or any other KPI we should be aware to and ready to manage?
Yeah, I mean, I think the model size, this is nothing new, I would say, fundamentally, generative AI or otherwise. We always had big CNN models, right? And then we kind of like basically compress them down because we want to run them locally for cost reasons. I think the biggest reason for being excited about Edge right now, from a purely practical standpoint, is really just worrying about your data privacy aspects and then kind of worrying about the cost, because these models do cost a fair penny if you're really firing them up continuously, right? And I think that's the unique value add as to why we actually need it on the edge.
But there's like roughly speaking, like it's about for every billion parameters, it's about a gigabyte of RAM or so of processing. There's just things like that where people are now sort of figuring out like, okay, so I can put like a 10 billion parameter model on a piece of equipment and put 16 gig of RAM in there, and I'm pretty much good. But that is one of the factors when you moving these models to the edge is the resources required to run the inferencing on them, right? So
yeah, I would certainly say that the requirements are much, much higher as compared to classic ML models. These models are definitely much harder to actually get onto the edge devices.
Yes, exactly.
And Vijay, do you think reasoning on top of small language model will exacerbate this trend of complexity, memory, and the
Yeah,
like?
certainly. This is where I think like we have to really get into very innovative hardware and software co-design. And I think like, if we can kind of break things down into these different, phases that I was kind of mentioning, right? Where you have some level of compute that's actually happening, then you have to have some sort of knowledge bank that where you're sort of, storing all your data, your memory, and then you're accessing it. I think it's going to be really interesting to think about what edge AI architectures would actually look like from SoC design. Like if I take a smartphone in the future, I'm kind of thinking 5 years from now, what's that smartphone chip that's actually got true generative AI capabilities going to look like? I don't think it's going to look like what it looks like today. Because today we're basically shoehorning the whole thing into an ecosystem that we have. Right? We don't really algorithmically sort of break it down. And this evolution is bound to happen because the algorithm people are going to figure out that, oh my gosh, like I really want to run this on the edge, but I can't do it the way I've done it conventionally. And we've seen this with traditional, convolutional models, right? That's the whole reason mobile nets came out, because they were like, oh, we can't really run a classic CNN model without a different type of convolutional operator efficiently on a mobile device. And I think like the same sort of hardware software co-design is inevitably going to happen.
So do you think that there'll be an evolution of the actual semiconductor hardware architecture at the edge to be more optimized? I mean, we talk about like neuromorphic computing and some other things where they sort of just like kind of started over, and said, let's design the hardware around the AI as opposed to the AI around the hardware. Do you think that that'll happen for generative AI as well?
Yeah, inevitably it'll happen because every phone or every edge device is going to want to have this in some capability. Right? Because the real power of this generative capability, generative models, is that they try to give you some sort of an insight. Now, whether that insight is accurate or not, we can debate about that, right? Because there are ways to kind of get around that issue of hallucinations and so forth. But I think the key thing is like in a traditional TinyML or Edge AI device, for example, we would often say, okay, well, I want to say, is there a cat or a dog? And I want to do this. Okay, well, let's say it's an elephant out there, somewhere in the forest. Okay, that's great. But generative AI is now going to be much more interesting because it's actually going to be able to not only just detect or recognize, but it's actually going to be able to synthesize the information and say, oh, this is the specific behavior of interest that I'm actually interested in. And that's that knowledge that I'm actually going to pass up. It's not about, oh, is there an elephant? Sure, that's one way of looking at it. But is there an elephant in distress? That's a different, right? That's real information. I think we're starting to get better at really extracting the real value as to why we're building these things.
Yeah. And I think it gets to the point when we had a few questions here around use cases, but the idea of like visual language models and things like that and adding context. I mean, we've seen some implementations where there've been kind of very low power sensors, image sensors, audio sensors, coupled with, a generative model running maybe on a box, some sort of gateway box nearby or across multiple sensors. But that, like you were saying, like it's not just like is it a hot dog or not a hot dog? It's more like, give me context around what I'm seeing. And the generative AI models can actually add that kind of capability to a lot of the sensor data that's out there. In fact, it's one of kind of I don't want to say the killer use case, but a canonical use case is like tell me what's happening, give me context about what I'm
Yeah.
seeing and hearing and sensing.
Yeah.
And that's where generative AI on the edge can really have some advantages, right?
Meta at some point was really using this term contextual AI on their
Mm,
edge devices and saying that, okay, if I have a smart glass, it's not just kind of looking at things, it's actually understanding the world around it. And now I think it's not about just understanding it, it's then being able to transcribe that into a totally different modality and informing possibly a blind user about, hey, this is actually happening, for instance.
right.
Not just that there's a car. Well, it doesn't help if you just know there's a car. The question is the car actually crossing right in front of you?
Sure.
Yeah.
Yeah, actually, so there's this is let's see, factory floor. There was a question around factory floor. So I'll just, that was kind of what we were talking about as an example. We've seen sort of the kind of AI vision used in factory floors for like, bounding boxes that says if anyone steps into this area, show a red light. But I guess in this case, we can use it for, using generative AI combined with kind of image sensors for, more contextual awareness about who's doing what, or is someone in distress, or what's exactly happening on the
Yeah.
factory floor, right?
I was just thinking that maybe it'd be interesting in a factory use case. It would be like, where is time really being spent? If I'm looking at it from an efficiency or optimization sort of standpoint, I'm
Right.
not interested in what is being done, right? It's more about how things are being done, because I know things are being done. Like if a person is lifting boxes and putting them in there, okay, well, I kind of know just, okay, there's a number of people, it's taking this amount of time to do it. Okay.
Yeah.
But then if I was to try and understand why is it taking so long, that's a different problem. And I think that's like an example of one of the factory use case you might want to understand. Why
Mm,
is it taking so long? Oh, it's because they're constantly having to open this gate that's sitting in front of them every time they have to go in to do something. Just contextually,
yeah, makes
it's
sense.
slowing them down.
I guess to your point about kind of ultimately getting these smarter hardware architectures to accelerate some of these models. I know Amola just asked a question around foundation models themselves. Do we need new foundation models that are more designed for
Mm.
kind of sensor input to really contextualize physical phenomena? So, is there we've seen like foundational model designed for the edge, quote unquote, right? So, like the 10 billion parameter, 16 billion parameter types of things. But is there a need or for some other types of foundation models that are more edge native?
Yeah, definitely. I think the unique value out of the edge, as compared to the traditional world that we're in, is that like we often interact with the physical world, which is what Emma was getting to, just spot on. Right. I
Mm,
think that's a unique thing about edge AI. Fundamentally, for me, if you ask me at a macro scale, what's different, I'd be like, oh, much of the cloud-based systems are not really. They're kind of dealing with purely digital data.
right.
But when it comes to the edge AI, then it's sort of that's the first time where these models are suddenly interacting with the physical world, and now that is a whole different problem. Right? And for that, to her point, yeah, we need to build new data sets, new sort of images, like all the classic things that you assume don't necessarily work over when you're starting to interact. But I think that's the opportunity that we really have, is that once you start talking about quote unquote physical AI, right? And I think that's going to unlock a lot of new capabilities, and there's opportunities in designing new systems. I mean, think about robotic systems. Robotic systems are going to be probably one of the areas where you're going to get the maximum lift from all these generative capabilities, in my head, undoubtedly.
Yeah.
Because that's
Yeah.
always been one of the Achilles heel for them, is that they don't understand the context simply by looking at
Right.
individual sensor points and just getting this raw data. They don't really understand what's going on. And this, I think, is really going to help lift those robotic applications, because suddenly they have scene understanding just from a visual standpoint.
Hmm. Context.
Yeah.
Yeah. I mean, traditionally, they've been very, robotics platforms, which have been around forever, have been very kind of if then else, uh, programmed, right? And they kind of freak out if there's the wrong context. So now it's like we're seeing that, especially in like warehouses and other scenarios where there's the ability for robots to be more context aware and smarter and more adaptable
Mm-hmm.
makes their value much higher. So that's definitely happening. And so we've seen all the physical AI and the Groot Foundation model from NVIDIA and a bunch of other things that are
Mm-hmm.
really designed for that space. Maybe that's kind of similar to what Amola was talking about. Here's a topic, and Danilo, feel free to chime in too. But
Yep.
there's one of the things we see with generative AI is, one of the memes out there is around hallucinations. and how, when a generative AI model creates something, kind of predictively creates content, sometimes it kind of goes off in a little tangent and you're not quite sure exactly if the output is authentic or not. I mean, is there an opportunity to mitigate that risk in the edge space, or just kind of live with it?
My first reaction is that it's actually going to get worse on the edge space, right? Because there's only so much processing you can do on a smaller model, right? So as you kind of get smaller, I think it only makes sense to actually just get them to be much more specialized, because that you can actually test.
Okay.
Right? It's inevitable. I mean, it's inherently, a stochastic model. And so you're going to get a little bit of that, right? And I also think it's important to kind of separate what we want as factual evidence versus why we're actually using generative AI. I often find that people mix these two things up, right? There's a pure point where you want search capabilities, like classic Google search kind of capabilities. That's just fact. Fact meaning there's some source it's actually literally pulling the information from, right? And then there's a part about the generative AI element itself, right, where you're actually creating new words out of it. I think if you start splitting things up, then I think you can actually get a robust, quote unquote, loosely generative AI on the edge. That's not, very subjective to hallucinations and so forth, because it is getting grounded. But trying to expect one model to do it all, I don't think that's a reasonable approach.
Right. But narrowing the data set, narrowing the training would help mitigate some of the hallucinatory risk, potentially.
Vijay, let me go back to one thing quite convincing to me. You just said about the application in the humanoid robotic space. What should we expect, in your opinion? Advancements on all the stuff from algorithms, hardware, energy efficient techniques, material maybe, as far as implementation is concerned?
In the context of robotics specifically?
Yeah, we in conjunction with generative AI. Yeah.
I think it's I think the kind of use cases that people have been talking about, like these humanoids and so forth, the physical robotics side, like the core robotics, I think is at a point where we can have some of these robots, right? They don't necessarily have to be humanoid robots that are able to perfectly walk and so forth. That's irrelevant, right? I think you could very well have a robot move. I mean, that's a good thing, right? It move on wheels, right? I think it's just, again, going back to that context element. I think it's going to be like, okay, how do I sort of leverage that context? And I think the biggest Achilles heel then is going to be very much in line with system architects, whether you can actually run the model, because there's one aspect of actually running the model, which is just task completion, right? Then there's an interesting aspect, then to the robotics angle, is obviously there's real-time constraint that you have to deal with, because the information has to run within a certain amount of latency to be able to be useful, right? And then, of course, then you have to ground that whole thing and make sure you've got all your safety mechanisms and your alignment mechanisms in place. And I think that triangle is going to be really interesting. That 3D space is actually going to be really interesting, because often we tend to think about, okay, can I get this functionality? Yeah, you can get that massive functionality. You can stick a giant ChatGPT, on a Roomba. Good luck, right? We know that's not going to happen. So that's the first thing we're going to do, is try and squeeze it down. Now, you can squeeze the model down, but then, of course, you're getting performance aspects out of that. But then, what ends up happening to that safety aspect or reliability aspect? I think that trade-off is what is really, really interesting, at least personally for me. It's like navigating that trade-off, I think, is going to be the holy grail for a lot of these robotic applications or autonomous systems.
Interesting.
Yeah. There's a question to that effect from Guillaume, this is more getting back to using generative AI with kind of sensor networks. How do we authenticate the data pulled in by the sensors and manipulated by the models?
Yeah, certainly. I think this kind of goes back to much of what the big models are actually doing right now, sort of using some of these other models as judges. Everybody's kind of specialized in certain things, and there's checks and balances put in place. And I think that's the way we're going to kind of build this.
Right.
I don't necessarily think we're going to come up with something radically different, because one of the nice things about adopting some sort of a judge-based model, for instance, is because we understand how to architect the system for that. Right now, what those gates need to be, that's a question that we have to figure out. What exactly should model X be looking at when it's looking at the data that's coming from model Y?
Hmm.
But that's controllable because that's a set up an API interface, right? You can say, okay, I expect exactly this. So you can codify that very cleanly. I think that's what the genetic frameworks are kind of heading towards, is that you're going to have all these different models and you're going to have nice clean interfaces that allow you to sort of understand the data that is moving through the pipeline.
Yes. And I agree. And then there's also this concept of, or this idea of how do we create some sort of safety certification around some of these platforms. And yeah, I think ultimately we're heading in that direction, so that people
Someone
know.
at some point is going to need to certify the models. ML Commons has an activity. There's a working group that's actually kind of putting together a recipe for what are the requirements for genetic frameworks right now. And it's like, how should these systems be evaluated? How should these systems be tested for reliability? Because we can certainly build them. I mean, I have a virtual classroom that I run, an AI classroom, in order to improve my book. I can talk about that later, right? But quality control is sort of like a nightmare in there for me. When they go rogue, they go rogue. And it's until the class is over, I don't find out that they've gone rogue.
Right. Danger Will Robinson,
Yeah.
Serious stuff. Hey, speaking of education, let's talk a little bit about education. I mean, obviously that's kind of your primetime gig. And generative AI, I think that we've had a lot of questions here. People want to learn, especially in this kind of nascent area of generative edge AI. People want to learn about it. They want to kind of explore it. They want to develop on it. But there's also how generative AI has been impacting education in general. And I know you've integrated some Gen AI capabilities into some of your processes, and we can talk about ML Sysbook and things like that. But what's your take on the impact of generative AI from a, I want to get more into it from an edge perspective, and also how it's impacted your own work?
Most of the time when we talk about AI technologies, we're often talking about, it's going to put someone else out of a job, right? As a computer scientist and an engineer, most of the time, everything I've built over the years has been like, someone else is getting displaced. It's not me getting displaced. It's a very rare thing to happen. But I would think that almost like when it comes to teaching and so forth, one of the biggest challenges is really that personalized education with global access. And I think that's remarkable. I genuinely believe that if we put the mechanisms and processes in place, I do believe that we can suddenly educate a whole new group of people with all the generative capabilities, because now I can kind of develop these models that don't need me to train a very costly teacher, fly them out and all that stuff, right? They can also learn by just kind of building these autonomous systems. Right? So imagine if you have a course in a box, literally, like physically a box. Right? A system that kind of comes with all the acceleration that's needed. It comes with an intelligent AI model, right? And it basically specializes in a thing. So in the future, maybe I'll just go to Amazon and then I'll get a course in a box, and it'll be literally a hardware coupled with an agent that specializes in a certain subject, and I can pretty much just drop this anywhere, and it has a mechanism of teaching people. And I think that sort of personalized education might really open the doors. And I think this is where I've actually been looking a lot into one laptop per child. There was this one laptop per child program.
Yeah, I remember that
a while back. And, a lot of people would say it was a failure for many reasons and so forth. But I believe that the dream was a good one. It was one of a good idea.
Yes.
And I think like those are bold dreams, and we should continue to dream and build on those things. And I think generative AI has the ability to kind of make those things more accessible. And so I was kind of mentioning this because, one of the premium things is teachers. Teachers are very hard to find, especially good teachers are incredibly hard to find. Right? And so I feel like generative AI, because it's got this ability to kind of adjust to different levels of students, or, you can chat GPT and say, okay, very often I say, explain this concept to my daughter, Nora, she's 9 years old, right? She told you, suddenly the whole language gets dumbed down to a certain level, and a lot of examples are used and so forth. I think that sort of thing is going to be very useful, because right now, in every classroom, people are kind of stuck with what you get. You get the TAs you get the instructor that you get.
Right.
And time is limited, resources are limited. But I think generative AI kind of opens us up. And this is why a lot of students in class, I kid you not, one day I was at MIT, I was just waiting for me to go up and talk. So I was sitting in the back, and unbelievable, literally every screen had a chat GPT open on the side. This was sort of like when it came out a couple of months. So it was still relatively new, but it was pretty incredible. And that's when I was like, oh my gosh, they're actually asking what the instructor just said pretty much in real time. So I think it's going to dramatically change the way we teach or how students learn. That was a long one because I think about this all the time.
Yeah, no, I could imagine. I mean, by the way, you mentioned about the one laptop per child. There's an organization. Actually, I'm involved with called Elevate Our Kids, and I'll show the little banner. But that is an organization to help provide equipment for folks in disadvantaged communities and just connectivity, laptops, just the basics. Because in fact, in a lot of these areas, especially in kind of rural parts, even the U.S., certainly worldwide, but in the U.S. specifically, if kids are not on the internet with a laptop, it's very hard for them to get a proper education. So Elevate Our Kids is an organization. If people out there are interested in donating to that, that'll help get people the stuff to get started, to get connected into their classrooms and things like that. So that's my little spiel. But you also have been working on this thing around ML Sysbook. Maybe you want to talk about that, and I'll show the little ticker so people can don't navigate away from what we're talking about, but you can open a new tab and check this out. But give us the spiel on ML Sysbook, because I know this has been kind of a huge collective effort.
So one of my personal missions is, as much as I love doing research and so forth, the other side of me is like, it's the Libra in me. Everything's got to be balanced always. Is really sort of like, as much as I push research, I've got to balance it with education and outreach. Because I often feel that, if you have the knowledge, one of the responsibilities is you have to disseminate it. If you're good at something, then you have a responsibility to pass it along to other people. So I've been quite passionate about sort of like, how do we make all of this AI education more accessible? Now, AI, obviously, from an algorithmic standpoint, there are lots of people who would teach, hey, like this is how you would, use a low code way of, training a model to know whether it's a cat or a dog. But I would say that what's happening is everybody is basically telling everybody you can be an astronaut. That's what everybody's setting everybody up for, right? That everybody's going to be an astronaut. You don't need to know the principles. AI is going to be some amazing thing. The thing that I think about is like, who the hell is actually going to get you up into space? Ultimately, you need a couple of engineers who actually make that thing happen, right? I'm not dismissing the astronauts, but I'm saying like someone else to build a rocket. And even if you just build a rocket and you're a rocket scientist, that's not enough. You need mission control specialists who can actually control that beast that's going up, right? So you really have to kind of think about that whole ecosystem. And what I would say in the last 7-10 years that I've seen is that there's this overemphasis on AI algorithms alone. And I think there's an underemphasis on sort of like building the rocket and what it means to engineer. Think about this. If you go back to the 1960s and 70s when computers were becoming a thing, right? There were algorithm people. There was computer science. People who were thinking of what is the algorithm? How do you write pseudocode? How do you think about a problem? How do you express that in a way that, we can actually convert that into bits? But then people very soon realized, wow, if computers have this remarkable potential to make us more productive as a society, maybe we should actually be training a big group of engineers who can actually build these machines so that we can all go and do incredibly amazing things with them. And so universities started creating computer engineering as a discipline. Now, if you look at it in the ecosystem, you'll see a lot of deep learning courses plastered around every campus, right? Because they all want to be AI. And the thing that you will find missing mostly is there's no AI engineering at all in that. So you can't have computer science without computer engineering or electrical engineering, because then everything just stays abstract in theory.
Right. Yeah.
So I think that's the thing that I've been very passionate about, is sort of how do you get the next generation of engineers? Where are the next generation of engineers going to come from? And that is what this MLSys book is. It's about machine learning systems. It's about understanding the nuts and bolts of how do you build an AI system that's capable of running these generative models, these transformer architectures, right? These CNN architectures. That, I think, is a fundamentally different skill set that has to be taught very systematically. And I think that's what I'm really passionate about. And so this open collective thing that we created, which is actually in partnership with a lot of the education stuff that we do with the Edge AI Foundation, is really kind of geared around how do we sort of, get support for running these workshops. We've been doing workshops, building TinyML kits with Arduino, including SD, and then of course, like, with Seed. So we've been doing a lot of these partnerships one-off, and we've been doing this for about 3-4 years. There are incredible people behind the scenes, like Marcelo from Brazil, and then Marco Zanaro from ICTP, and Brian Plancher from Dartmouth. So a lot of people have been doing incredible work and kind of putting materials together to make a lot of this information globally accessible. right? Which is, sponsoring kits, trying to build kits that cost only $10, which maybe in the US is not such a big deal, but by the time you get it out there, it's quite costly. So the collective is kind of geared around that whole mission of like not just getting the content, but also making that content accessible in a way
Right.
that can actually reach people. And our goal is about trying to get to 1 million, trying to train 1 million people by 2030.
Mm-hmm.
Right?
Mm-hmm. Yeah. Yeah, no, it's awesome, and we've the Edge AI Foundation has a scholarship fund, and we have programs where we've underwritten these programs in Malawi, and I think we have one coming up in Colombia, and our goal is to double that next year with this effort, so that we have, instead of 2 per year, we can do 4, and if not, and also like programatize this stuff. So like you said, so it's more in a box. I think it's also about proliferating this curriculum, right? So that more colleges and universities pick this stuff up, and high schools too. So like you said, so my degree is in computer engineering. So I was kind of electrical engineering, computer science combo guy back in the day, because it was like pure computer science, like, yeah, it's cool, but it's pretty theoretical, right? You kind of sit there and draw stuff on the whiteboard. But with when you get into the kind of the double E world and other things, and you start to think about like, bits and registers and things like that, then it starts to get real. So I totally get the fact that we need more engineers focused on this. And I don't mean prompt engineering. I mean actual real engineering. No offense to the prompt engineers out there, but that's a whole other topic for me.
And Vijay, there are lots of fresh engineers, young professional, which are quite experienced now after years on traditional fixed AI. So, do you think your approach, which it's centered on the educational aspect for sure, will also scale to them? Also these people maybe will go to a point where they should change once again the way they develop AI.
Yeah, I certainly think it is important, but I think the most important skill set is really going to be just understanding this, right? Because to our earlier point when we started, yes, there's an incredible amount of change, and so we will see new configurations of how these different blocks are put together. So I think the question is sort of helping these engineers understand what to really focus on, because I think the one thing that engineers that are already out there are struggling with is everything is changing, everything is changing, everything is changing, and so what do I actually focus on? Because if you get on LinkedIn or you get on Twitter, your head's going to explode, because every day someone's posting some new paper that's come out, right? I mean, my LinkedIn feed is unfortunately completely, that recommendation engine is completely biased toward generative models, right? So I don't see anything outside of that. Then if you're an average engineer where your job is not to kind of track that, then I think it becomes really challenging. So what do I really need to know? And I think this is where like, I know that the Edge AI Foundation has got some ideas around kind of putting together some sort of certification courses, working with the sponsors of the Edge AI Foundation. And I think something like that would be very meaningful. So where we try to identify what is a base core set of knowledge that you should have, independent of what's happening at the application level, and then try to build tiers of that. One could just be like, oh, let's assume you don't know anything about AI/ML. Here's what the language is. Here's the terminology you should recognize so you can actually have a useful conversation, or you can at least craft conversations based on that language that you learn. Then, of course, you're going to have a second tier, like let's say a 200 level course, where you're actually getting exposed to, okay, these are the different kinds of applications. Now that I know the language, I can actually think about the different kinds of applications. Then the third tier would really be about deploying things. Now that deployment thing, I don't think is going to be interesting if we just arbitrarily pick a platform. Because at that point, I think it makes sense to say, for example, Danilo, like, you want to hire some engineers in Europe, for instance, like it might be useful for ST to be saying like, okay, we will, assuming you have done courses 100 and 200 level, the 300 level is something we specialize in. You will get to work with production platforms. You will actually use ST Microelectronics, official commercial tools, right? And that's part of the thing that you plug into. And I think if we do that, then we'll actually be building pathways, not just for students that I deal with, but for the engineers that are actually in the real world that want to actually adapt.
Yeah. Professionals.
Indeed. Yeah, absolutely. Yeah.
Well, there's always the discussion of, we have a lot of folks kind of in the edge and embedded space that really don't have the AI chops. And then we also have a lot of folks kind of doing Python AI stuff up here and don't have the embedded edge chops. And really the goal is to cross-pollinate that. And I'm just showing a URL at the bottom. So if you go to edgeaifoundation.org/learn, we've tried to collect a lot of these resources there. We talk about our scholarship fund and the stuff that we're underwriting there. We have links to ML Sysbook. We have links to some pretty cool free courses out there, Coursera as well. We'll be launching our own kind of certification, knowledge certification program there. So, and there's also links to lots of live streams. So yes, I think that is kind of the goal, is to like, how do we get all these folks educated? And some folks, like maybe there's undergrads in there and or even high school kids, but there's also a lot of folks kind of, mid-career, late career, right? I know a lot of embedded engineers that have been doing this for decades that would love to kind of brush up on their AI chops and figure out how to really add that to their skill set. So I think there's a lot of opportunity here.
I was actually thinking, this is a wild thing. Don't say that I'm committing to it, but I have this wild idea as part of reaching our vision of having 1 million engineers and 1 million people educated in the space. I was thinking of doing something fun where it said like, oh, if people donated money to support all of that education, then I'd be happy to meet with the engineers, because the engineers have the money, they're making the money, right? So they can spare some. But in exchange, I can meet with the engineers, and the engineers can certainly pick my brain all they want about career trajectories and sort of where the field is going.
Right.
So that's sort of a wild idea that I was playing around with yesterday. I was like,
sounds like another barbecue in the planning phases, right?
Yeah.
A cookout in Cambridge for all these folks.
I kid you not. I was literally thinking about that. I was like, oh, it'll be cool to have a Lexington Learn session, like where, people love my barbecue, so they're always over for barbecues. And I'm like, it'll actually be fun to kind of learn something. Maybe one day I'll teach about AI to my neighbors. Another day, the doctors can teach me about what they do. Then we have a couple of rocket scientists
how to do surgery, stuff like that.
Yeah. Learning's got to be a bit more fun than just kind of taking classes online.
No, I know. Well, yeah, the interactive part of it too is, I was just talking to Danilo. Danilo's based in the Milan area. We had an event there in July. Unfortunately, Vijay, you weren't able to make it. But we had 3 days there of workshops and talks and demos and a lot of hands-on stuff. So the in-person learning is really important, I think. And in as much as we are all connected digitally through these little squares and little videos and microphones, the in-person stuff and the hands-on stuff is really important too. So, and how do we scale that? Like you said, if you go to our YouTube channel, there's a little video on the Malawi event that happened back in March. And so investments in these kind of bringing the knowledge to the community is really super important. And especially now that we're talking about generative AI, it opens up a whole new range of skill sets. And I know for the Columbia program we're going to do in the fall, by Columbia, I mean Columbia, South America, not Columbia, New York City. We're going to, I think, have some generative edge AI labs and some other new things there too.
That should be very, very cool. Yeah.
In fact, Marcelo, who I mentioned earlier, has been helping with a lot of the labs, actually put in some generative labs in the MLSys book.
That's right.
How to use generative AI at the edge.
I think the other call to action here we had was, and we'll put this in the chat as well, but the paper that you recently published around generative AI, I think that Danilo, I think this is the paper that we were talking about recently. It's another good call to action for people to take a look at that. And in fact, I can put that in the chat actually if I hold on for a sec.
Oh, I just saw the comments. I didn't realize I could actually see the questions that people are asking.
And what I particularly liked by this paper, Vijay, you wrote, was the effort to introduce a taxonomy on generative edge AI, and also how these taxonomy correlate with implementations, with potential implementations, and that is very informative, because really what at least in the working group, I'm chairing this working group with generative AI, and really one of the challenge is to share a taxonomy with everybody, and so that we speak the same language. You say that the tier 1, at least the terminology is common, and then there are the other levels with increasingly higher complexity to manage, which is absolutely important. So I think your efforts in this direction are really helpful, definitely. and I look forward for MLC's book with generative AI extensions soon. I hope it will happen soon.
Let me share something. Okay, so this is it's a working project. So it's not ready yet. But
I'm also going to put in the chat a link to our Discord server. So we have a few thousand folks on our Discord server doing kind of edge AI things. So it's another resource for people out there that want to introduce themselves and kind of learn some new things. But yeah, no shortage of things. If you go to our Edge AI Foundation /learn, that's designed to be sort of a collection of all these links. But go ahead, Vijay. You're going to show us something, some new unreleased stuff.
Well, I just kind of dropped the link on it. I was actually creating just a framework because I want to be able to teach people. And actually for resources, and here's another link that we just kind of put together recently.
Let's see.
I'll drop that link.
Someone mentioned Coursera certification. So there's an Introduction to Edge AI Coursera course from Edge Impulse there that's really good. It's probably a year or two old, but it's a good introductory course. I think it's free. So just to answer that question about Coursera. So you put in there you go, mlsysbook.org. Got it.
Yeah, so that's sort of a landing site that we had for all the materials that we've been kind of pulling together, which is the book and then the access to the kits, and then these other community resources and so forth. Because again, we're just trying to rally all of the content together in one place so we can actually make it easy to share. I do want to mention I want to catch one particular comment that was made because Samnath says Samnath Mukherjee said people need a good math background to understand where novel things are coming from. I fully agree with that, but often I also want to say that as much as we do need the math underlying principles, it's not that if you're an engineer you need to go pick up linear algebra and all these things at the nuts and bolts level. Now some people will get really fired up by the fact that I just said that. What I'm trying to say is that I think there is this, there's a camp of people who are like, oh, you really need to be a math expert. You need to be able to do this and all that stuff, right? Well, I'm sorry. If I tell you about a conventional computer program, if you think you're a programmer, I can totally dismiss you from saying that you're not a computer scientist because you don't understand theory. Many people won't even be able to pass a very simple set of, big O quotation, big O notation, for algorithms if I ask them one-on-one today. But that's not to say that they're not programmers.
Right? Sure.
It's about efficiency and so forth. So when it comes to ML, I often hear people saying oh, you really need to understand the math, and people think, oh, I can be an AI engineer and so forth. And I do think, yes, you can actually be an AI engineer without necessarily knowing all the math, because you're not trying to prove the math. You're trying to use.
Yeah, you don't have to prove the math. I mean, you don't have to do fast Fourier transforms by hand and pencil.
Yeah.
To be a programmer. That being said, most of the engineering programs out there, if you get an undergraduate degree, a bachelor of science, you're gonna take a lot of math.
Yeah.
Whether you want to or not, you're going to be taking 6 or 8 semesters of calculus along with that. So, but yeah, people can jump in as a programmer, right? And that's distinctive than being an engineer. It's just not all programmers are engineers. Not all engineers are programmers, but
yeah, and that's just fine. Right. But I think it's a very good point that a person brings up is sometimes he or she is right in that, yes, if you're looking forward, then yes, you definitely need that understanding of where things are going, because the math is kind of driving, where these models are going to unlock new capabilities.
Right.
From a fundamental standpoint.
True. So we got a few minutes left. If we have some other questions, or Danilo, if you have any other key points.
Yeah, maybe a hot question, Vijay. Will generative edge AI take over on traditional AI, or somehow they will coexist? I mean, it doesn't matter, but all the investments will be lost at some point in time. Like the video codecs that kept evolving, the multimedia video codecs, and one made obsolete the others. And
Yeah, that's a very interesting question. Now, I'm going to put my hat on as an academic, all right? And my job is to help you folks kind of think a little differently. So here's where I think about it. Like, when we look at sort of chip design, semiconductor industry, like, we do a lot of specialization right now. Domain specific specialization is the only way that we get efficiency, right? If you look at any smartphone from Google or Samsung or Apple or anybody, they've got lots of specialized Formula One race cars for video coding or transcoding, or like, just listening to MP3s. Now, I think that worked okay to a certain extent, right? That was in a very specialized domain. But now we're talking about, hey, like, we want to run the entire world, with all these specialized blocks because of, Dennard scaling has ended. Basically power efficiency has become a very big problem. So we need to build specialized things for everything. And having consulted for some companies, which I won't mention for a while, what I realized is the companies kind of come up with these incredible POCs and say like, oh, wow, like, look at this incredible device that I have. But they won't tell you about the incredible amount of engineering effort that actually went in to make that, that demo, right? Now, if you think that the whole world has to run like that, and then you kind of open that hood up and you see all the specialization that is done at the hardware, semiconductor level, right? Hardware accelerators. I don't think we're going to be able to build a world like that, where everything is specialized, where you're going to have a specialized processor to run your Microsoft Excel, you're going to have a specialized processor to run your Chrome browser. That was okay to an extent. Certain areas will have that. So if you look at investments that companies are having to make, it's getting very, very costly because the tool chain actually doesn't quite exist to build those kinds of things very efficiently, right? So the 50 years of general processor CPU innovations that we have taken for granted are getting like pretty much tapering out. What this fundamentally means is that we have to kind of rethink how we do design. So rather than building individual specialized accelerators that are highly specialized for video, this and that, maybe in the future, your entire quote unquote new CPU, right, is just going to be an AIPU. I'm just making this up, right? And you're going to have maybe 50 of these variations of these neural network accelerators sitting on the die, right? And they're specialized for different things. Maybe some are specialized for, these generative core, KV cache embeddings, and KV caches, another just for kind of storing and accessing embeddings intelligently, something like that. So if you think about AI first system design, maybe it'll look radically different because that becomes the general purpose. Because one thing we have started realizing is that much of the classical approaches are being inhaled by the data-driven approaches. So maybe from a system standpoint, that's a different way of kind of thinking about how we create computing platforms that are fully based on just neural processing units, just a sea of NPUs. And what would that look like? Right?
That's fantastic. Yeah, very interesting.
Because that's much more cost effective. Because you can build the hardware and you can templatize that whole design, you can test, verify all that really well. And then you push the software people to come up with, hey, just get me a better model that can do this, right? And find how to map it down. I think that's much better than, oh, this particular, object recognition scene kind of thing has this particular, set of algorithms that I have to hard code. By the time you hard code it, they're going to say that something has changed.
Right.
So it's a fundamentally different way of thinking about it. What if forget the CPU? Just it's all
NP.
Yeah.
Well,
Vijay, you've given us a lot to think about. We have about a minute left. I was going to say before people leave or bail, I wanted to just show our scholarship gear link. So if you want to help fund some of the stuff Vijay's talking about, the Edge AI Foundation Scholarship is a good place to put money into. One way to do that is to buy some cool Edge AI Foundation gear. I was mentioning to Vijay and Danilo, we now have tank tops in there. So if you want some beach wear this summer to show off your guns, you can get some tank tops there and some other stuff. But that money goes into the scholarship fund that helps fund things like Malawi and Colombia and other things as well. So, and you got some, tumbler and all that, whatever stuff. Get your coffee. So, Vijay, any closing thoughts in the last 25 seconds?
It's just going to be a super fun ride, people. So don't miss it.
It will be. It will be. Well, thank you, Danilo, also for your time.
Thank you.
And all this stuff will be on YouTube, so people can head over there and rewatch this at their leisure.
Thanks, Vijay. Thanks, Pete.
Awesome.
All right. Thanks, everybody.
Bye.